Is somebody wanting to make a comment at the queue or? Leave queue. All right. All right. I think we're pretty good. I think we're about ready to get started here at IETF 114 in Philadelphia. Thank you all for coming. Should we just? We're missing one chair. I think. All right, we'll get started with some of the formalities here. Thank you for coming. Once again, please check in with the on-site tool and wear a mask unless you're presenting at the front of the room. And you are all probably familiar with the note well that governs the various policies here at the IETF. Here's some code of conduct guidelines we'd like to remind you of: to treat each other with respect and speak so you can be understood. These are generally good things. We have a minute taker, and hopefully there are some folks on Jabber who can help us if there are things that need to be brought to the mic. Always remember to state your name. All right, do we have any agenda bashes? I know we do have a request to move flags extension to the end to accommodate a presenter who could not make it here at the beginning of the meeting. Any other requests to for the agenda? All right. You want to go talk about document status?
Yeah, so hey, we got some stuff done since last time, believe it or not. We got DTLS 1.3 out the door, so thanks to everybody for that. Ticket requests and exported authenticators. Jim Reed asked me about when DTLS was going to be done about 2.5 years ago. My crystal ball was really wrong, by the way. We have 2 other drafts, the remaining PSK related drafts that are in off 48 done, which basically means they should be published at any time now. We've got delegated credentials, aka subcerts, which I believe is on Paul's plate, so we need to make sure that he gets through and reviews that. We don't have anything in IETF last call right now. We have 2 drafts that we paused, the cross SNI resumption and TLS flags extension, waiting on implementations. I think we're going to go ahead and revisit that. And right now we have the RRC for TLS 1.2 and 1.3 that is out for working group last call right now. That actually ends August 5th. And then everything else that we have in progress, which we'll talk about today. And I think that's it. I think we're going to go to the presentations, and then we have a slide at the end. So these are some stale or expired working group drafts that kind of were adopted and then kind of got put by the wayside. So we're going to try to kick off a discussion on list about whether we're going to try to bring those back or just let them gracefully die.
All right, CTLs. I believe that's Ben.
Do I have a clicker or?
I think I do next
okay.
slide. Oh wait.
You can try this one.
It's all right. I'll just. Okay. Hi, I'm Ben Schwartz. Wow, this sounds loud. I recently joined as another editor or author on this draft, and I'll present some updates on the changes to this draft in version 6. Next slide. So there are a bunch of major changes. Draft 6 is very different from Draft 5. Okay. One big difference is with profile IDs. Previously, it was not, these were just kind of free form. Now there's a reserved subset of these. There's an IANA registry. Another really important change is that CTLS is no longer specified as a compression layer. Instead, this draft specifies CTLS as a protocol generator. So you define a profile, and each profile defines a unique TLS-like protocol. But it is not a compression system. It is a new compact TLS protocol. Related to that, there are now binary objects describing the templates. And finally, there's a new system of handshake framing. And I have slides to go through each of those points. Next. So the profile IDs as byte strings. Profile IDs are now defined as sequences of bytes, 1 to 255. If there isn't one specified, that means you're using default CTLS. In other words, you're using the CTLS syntax, but you haven't subsetted the TLS standard in any other way. If you use a short ID, an ID whose length is 4 bytes or less, that is subject to IANA registration. And in that case, your template only includes the profile ID. The recipient has to understand it, has to recognize it as being something it already knows from the IANA registry. So that means these can only be used in cases where the server knows that the client is going to be sufficiently up to date that it's gotten this entry from the IANA registry. Longer profile IDs, longer than 4 bytes, are essentially they're not registered. They're free for anybody to use. They only have significance within a specific deployment. And the profile then, after the profile ID, proceeds to lay out all the information that's required to understand what that profile ID means. Next slide. Okay, CTLS is no longer a compression layer. Specifically, the previous drafts of CTLS structured CTLS as a layer that sat basically between TLS and its transport. So in principle, you could take a totally standard TLS 1.3 stream and then, like, maybe even literally in a middle box or in some sort of middleware, you could take that encrypted stream and convert it into a CTLS stream, and you could convert it back on the other side. It was a transformation that didn't require access to any of the secrets associated with the connection. That has positives and negatives. We can talk about it, but it seems like the net consensus after the last discussion was that we would rather have CTLS authenticate its own transcript instead of reconstructing a TLS transcript and authenticating that. So the new draft does this. It authenticates its own transcript. Reconstruction is therefore no longer an implementation requirement. You can implement CTLS without having to reconstruct the corresponding standard TLS handshake, but this has its own problem. CTLS transcripts are very condensed because they omit a bunch of information that's very important on the assumption that both sides already know it. And so now, at least in some use cases, we want to make sure that both sides actually agree on that information that wasn't exchanged because they somehow was already configured ahead of time. And to make sure that it matches, we've adopted this solution in this draft where we take the shared information, the pre-shared information, which we call the template, and we prepend it to the transcript. So it's present in the transcript on both sides. And so if there's any disagreement about that, the handshake will fail. Next slide. Of course, putting the template in the transcript and then hashing it into the finished message means that both sides have to agree on it exactly. And in draft 5 and prior, the template was described as a JSON object. I can imagine that nobody here would be very excited about trying to figure out how to get byte exact hashes of JSON objects that are being passed around. So in this draft, there's still a JSON format defined, but there is also a consistent, reproducible binary format defined for the templates that allows us to consistently hash it into the template. And finally, there's a new system for framing the handshake. Previous drafts were a little bit ambiguous, I think, about how the handshake was framed. We've decided to cover all our bases basically by supporting both a full-size handshake option, which allows you to send giant handshake messages and fragment them in DTLS, reorder them, have them be reassembled in the right order, all of that good stuff. But in the case where you don't need gigantic handshake messages, you can disable all of that and save a few bytes and just have each of your handshake messages in a single record. So this draft is definitely still a work in progress. There are a lot of open, interesting questions that I've attempted to highlight some of them here, but there's a lot more details open in the draft, a lot of highlighted open issue or open question tags in the draft. So I would encourage anybody who's interested in this to read the draft and think for yourself and maybe help the editors think through some of these questions. I wanted to specifically thank Ilari Liosvara, who made a bunch of very detailed and helpful suggestions on the mailing list.
I think I'm up. Yeah. First, Ben, thanks. I want to thank you for picking this up. I've been a little swamped, and I really appreciated you picking the ball up. Sorry. So I think this first point, yeah, I think that the answer is almost certainly what you have listed here, which is that if we want compressed elliptic curves, we should just define new code points. After all, we already have compressed elliptic curves for X25519 and X448. They just come that way. So I think P256C, if anyone still cares to use NIST curves and wants them compressed, is the right answer. And of course, TLS 1.3 doesn't have very many curves left anyway. I'm not sure how I feel about the rest of these. I'm a little scared about the omitting the empty messages, to be honest. But I think I'll take that offline.
So on the omit empty messages point, I'll just point out that that is text that is in the draft right now. The draft currently says that empty messages can be omitted, but it also has a question in the draft about whether this is going to work.
Right. So that was probably something I wrote, when I was half asleep.
I forgot to check in. Oops. One of the things that Ilari also raised was the relationship to DTLS 1.3, and initially we wanted to have it defined in a way that the compression works for both DTLS and TLS, because for apparent reasons, because the protocols at the handshake layer are very, very similar. But I think that's also an open issue that we hadn't really gotten to yet. We had at one point in time, we had worked on the framing format, the underlying record layer framing, and changed that numerous times. But I think that's should be added to that list.
So I'm not sure I understand. I'll note that this is a conversation between the editors, so maybe it can happen offline. But I do think that the current draft, essentially, the current draft is no longer a compression layer. It's its own protocol, but it is essentially a system for generating both streaming protocols, streaming security protocols like TLS, and datagram-oriented security protocols like DTLS. I do believe they're both fully covered now.
Right. And that was an intention, and Ilari raised that question because he was in his email. He was saying that he doesn't see the need for this. Where I actually see the need, I'm not entirely sure whether we are fully there in specifying sort of the functionality for both DTLS and TLS. But yeah, I think that's something prototyping will help. Whether we are really there yet.
Thanks. I interpreted that message as actually supporting the work to make sure that it was clear that this could be used in both.
Okay.
Martin Thompson. So the empty messages one bothers me a little bit. We have, I think it's end of early data is probably the one that bothers me the most here. We need that one, and we need to know that it's there because that's a signal that we use to determine the transition point. It's not necessary in the datagram versions, but it is necessary in the stream versions. Otherwise, we wouldn't have added it. So I think we can't omit them, and it's probably better not to worry about that sort of
Okay.
optimization.
I think that sounds like a strong argument.
And the other one that I got up to speak about was the versioning. As long as you have some sort of context string that goes into the transcript, you can change it later. You don't have to worry about putting a version number in anywhere or anything like that one. Just change the context string, and I think that'll be fine.
Yeah, we did put a version number in at your request, more or less.
Yeah.
I think I like having a version number.
Yeah, I mean, whichever way you do it. The problem that you need to solve, and I'm not sure if you've worked through all of that, is that if you have a version number, you have to have expectations about how people handle a version number they don't understand, which I imagine at this point is don't use the thing at all.
Yeah.
Yep.
Hey, Stephen Farrell. Oh, sorry, am I next? Yes, I am. So now that you mentioned that instead of any compression there, it's now generating different protocols. Will the security properties of all of those be the same or subtly different, or could you make one horribly broken version?
I think Ecker is going to answer your question.
The compression doesn't affect that one way or the other. All the analyses of these that I know of were done at a symbolic level, assuming that ignoring how things were generated in the wire. So, so like let me just be clear. As far as I know, it might be possible to produce a profile that was horribly broken, where you say like all the max were 0 or something, but I do not believe there's compression not affects that.
Sure. Okay, but maybe I'll ask the question differently. The goal is still that all of the sane options here will have roughly the same security properties as TLS 1.3.
I think that is right. We do expect to have some formal analysis, although it's very tricky, I think, to figure out what exactly the question is.
So let me just like try to narrow that very slightly. There were a number of proposals to make, so I think roughly is doing some work here. So as a concrete example, supposing that you make the transformation that some people try to make, which is you remove the finish max and you replace them and you rely entirely on the AEAD, then you don't have you see between the key exchange and the encryption layer that we ordinarily would, right? And so under those circumstances, for instance, it would not be safe to replace the cipher suite with one that had a very short MAC as well. Whereas it would be quasi-safe with TLS 1.3 as long as you knew what you're doing. Quasi, by which I mean, like, of course you have a short MAC, and so you get what you get.
I think Yeah, Jonathan's next in the queue, Hannes.
Oh, okay, online. Good.
Can you hear me?
Yes.
Yes. So, two things. One, I actually spoke with in chat. I don't really care if we omit empty messages per se, just so long as there's only one valid way of doing it. Like either everyone must omit or no one may ever omit is fine. But just like, even if you say both must be accepted, people won't implement that. And with respect to formal analysis, I think the only version that, the only analysis that I'm aware of that actually models the wire format is the one we did for TLS 1.3. I think all of the others already omitted the wire format. So given that this is mostly a wire format change, I think that's where you'd have to start for formal analysis.
There were two other things we tabled absent the formal analysis, and maybe we should do it the other way around. We describe it and then have the community like Kartik and Jonathan to do a formal analysis is the use of the randomness or random numbers initially in client hello and server hello. That was, we debated whether we can get rid of those. And the other one was to omit the finished message. And that may be another sort of exploration, because those would be actually some optimizations in terms of messages being transmitted as well. I don't know if that is captured in one of the lists, because we had those discussions earlier in previous presentations, but we didn't come to a conclusion on those.
Yeah, I think that some of those points are covered in the sort of open questions embedded in the draft text, but I don't have them covered on this slide.
Okay, all set? Perfect. Thank you, Ben. Next up, we have Stephen for well-known ECH.
Great. Thank you. So next slide. So this was presented back at Dispatch in IETF 113. There was some discussion on that list, and it was eventually ended up on the TLS list and was discussed there. But it was presented previously. Just roughly, do people want me to kind of go through that presentation content again, or will I skip through it quickly? How many people would like me to skip through it quickly? Good, that's a plan. Okay, next go. So here's a summary. Basically, we have ECH test servers at that URL. ECH keys are updated regularly and need to end up in the DNS, and they're generated by the web server. And so that creates a problem for our setup. And this proposes a way to kind of deal with that problem. It's not the case that this is intended to be the one true way of publishing ECH keys. There's probably much more simple ways that will work for lots of people. And next slide. So there's an example, basically using a well-known URL to get the content to put in the HTTPS resource record. And next slide. There's a resource record. Next slide. One of the things about this is I don't know anything about CDNs, but some people do. So I had a meeting at lunch with Rich and Ben Schwartz, who had raised comments on this, and they've agreed to kind of help with the draft and be co-authors. So that should help that. So next slide. There's a picture. Next slide. Stop me if you want me to go faster or slower. It kind of works. It's a work in progress. It'll probably change a good bit. Next slide. There's a description of what's in the response, which is relatively obvious, I think. It has the ECH config list, a TTL you'd like, and which ports on the web server are using that. Next slide. Okay, so these are the questions. These are the issues that were raised on the list, mostly from Ben, and thanks again, Ben. Next. So an alternative you could think of for how to get the ECH information out of a web server is to use the retry configs. And that could work, I think. The idea is you just make a kind of a greased connection or something to the web server, and it would give you the retry configs, and then you could go and publish that in the DNS if you like it, and so on. That would require changes to ECH to the draft, because for a few reasons, to add the extra info if you need it, like TTLs or ports, whatever. And also, it's not clear that the set of keys loaded in a server at a given moment is exactly what you want published in the DNS at that moment. So you'd have to say something about what to put in, something more about what to put in retry configs, which we don't currently. So you could change the ECH draft and do it, but I don't think that's really satisfactory. So I think that doesn't particularly work well. We might change our minds, but that's what I think. Next one, unless somebody, if you have any comments or want to disagree, just jump to the mic, please. Another comment was you could create another resource record somewhere that basically says, here's what I'd like into an SVCB or HTTPS order. Again, that could work. The difference is you'd lose the server authentication that you get with the well-known URL. Exactly the properties of having that server authentication is something to think about, but you'd lose it. And again, for at least for my setup, it wouldn't really solve the problem because I still need some way to get the public key for ECH out of the web server and into the DNS infrastructure. So I think the same about that. But again, I might be wrong. Next one. The question is, so it looks like this, in theory, you could be much more generic about this and say, we'd like to provide a mechanism for a TLS server or a web server to publish everything it wants in a SVCB or HTTPS URI, and that could get very complicated. And so you could aim for more generic. It seems to me, at least for now, that it's the ECH keys that seem to be changing regularly, and that's kind of motivating this, and seems to be maybe a better approach is to try to do something ECH specific. Ecker. Okay, next. A point that Ben raised, which I think is fair enough, is that you may need ALPN information in this to publish in the resource record. And I think that's correct, so that should be added. I don't know what to do about the no default ALPN really. So yeah, you can ignore the slide now for now unless we get into a discussion about it. Next. There could be other content that you'd like to see in HTTPS RRs that end up essentially reflected in the inner client hello in ECH. And if there is, I had a look through, I didn't see anything obvious, but if there is, we should think about that and then probably add it to this mechanism if we go ahead with it. And next. SVCB is a kind of a bit of a mystery to me, to be honest. It allows some complicated options, it seems. So I kind of had a look through it, and we need to kind of think through some of the other use cases that exist and make sure that we're not doing something stupid. Yep. Other points that were raised in the discussion. Rob made a point about not mentioning that shared and split mode topologies. Emnot said it might need a well-known URL. That's fair enough. Ben said the path was wrong. I didn't understand why, but never mind. And lastly, I think that looking through it recently, there's either you have a port prefix queue name in your HTTPS RR, or you can have a port in the HTTPS RR, which I didn't understand what the right approach to that would be. And we have address hints that can go in these RRs, and I don't know if they should be reflected in this or not. And I think that's the last slide other than process slides. On one more.
Well, that's my cue, actually.
Okay.
So when we first designed ECH, one of the problems we were concerned with was desynchronization between the ECH configuration and the IP address. And so this is addressed in, and so the concern here, right, is you have two CDNs, right? And so you have access in front of them, and you get the ECH from one and the IP from the other, right? And so this is addressed in standard ECH by having the whole thing blocked up in the HTTPS RR, and then the one sort of lacuna is the retry mode with the public name, but that happens like seconds afterwards. And so like if you change your topology on that case, like sorry, you're bad day. But because you have a long TTL, you allow a TTL here, there's much longer than that is not seconds, but is like hundreds of seconds. That easily can produce the situation we're talking about here. And so I'm trying to figure out how you think that is fixed.
Sorry, I didn't quite get the question. Sorry.
Sorry, yeah. So if you will, because this structure allows the client to cache the ECH configures for a very long period of time, right?
The HTTP client.
Yes.
Yeah.
Then you can easily run a situation where you have a topology shift underneath, and now you're talking to a CDN which doesn't in fact handle this user at all, or does handle but has a different ECH.
I think Ben behind you looks like he wants to answer the question.
So I think the distinction here is that this draft claims that the only HTTP client for this is running inside the authoritative DNS server. This is only for communication between an HTTP server and a DNS server.
Or yeah, some DNS infrastructure, yeah.
Okay, so it's not. This is not for use like by clients or unaffiliated.
That's not the use case I have. We should think through what might happen if somebody else starts to use it. Yes.
Okay. So I'm provisionally prepared to believe that like it's fine under the situation, under the case you just laid out, Ben. But then I think it needs a very clear warning that this is not a replacement for HTTPS RR for generic clients, because we don't want people getting in that box mode.
Sure, that's definitely not the intent for this. Yeah, I agree. Okay, it's just before you go, Ben, I don't know. So the next steps, basically, I had a meeting with Ben and Rich. They're going to join as co-authors, they said, unless they hate me after this. And we'll ask the chairs whether we should create a Git repo for this immediately or whatever. And I think ultimately the aim would be to, whenever you hit publication request for ECH, maybe to look for a working group last call round about then, but not before.
Okay, I think we have Ted online.
Thanks. So one of my points was actually, I think, covered to some extent by Edgar. I'm a bit concerned here that the caching infrastructure that's there for HTTP is not really being considered by this draft. I think your answer that this is intended for a very limited use case of the HTTP a server talking to a specific DNS infrastructure somewhat removes the possibility that there's a random set of transparent caches in the middle. But especially if you think there might be a different use case in the future, you really do need to think through what the caching architecture looks like here and the interaction between the time to live that might be present in the HTTP caches, which is not always obedient to things in the instructions, and how you would deal with that, like whether you'd use e-tags or something like that. But the other bit of this is really, this doesn't sound real baked yet, but the well-known URI registry does allow you to register provisionals. And I would suggest that if you go through 8615 process, the one thing you might actually do here is register a provisional and run some experiments and write this as an experimental document to see whether this turned out to be worth doing. Because it looks to me from the description like a lot of what you're trying to tackle here is the case where the people who run the HTTP infrastructure don't in fact also control the DNS infrastructure and therefore can't use one of the other DNS related mechanisms for this. And a little bit of experimentation to find out what uptake you get on a provisional version of this might actually be useful for figuring out whether this ought to be permanent or generalized or something else. Thanks.
Okay, 2 good points. Thank you. Who's next?
Ben Schwartz. I'll just say I do prefer the more general approach here, where, as Stephen well knows. I think it would be better to not just convey ECH, but treat this as a general way for HTTP origins to describe themselves to their DNS infrastructure. But Stephen and I are going to spend a lot of time talking about that, and we'll see where it goes.
Yeah. The authors will agree at the end.
So I guess I'm up next, Ben Kaduk. So on this question of like, is this mechanism just used for the DNS server to talk to the HTTP server and get its config versus being used by arbitrary HTTP clients? I think if we do want to limit it to just the DNS server being the thing using this, that's actually a reason to specifically not have a well-known URL, because then it's explicitly something you have to configure, and that gives us more confidence that random clients are not going to try to use it, and we don't have to try to think through all of the behavior and consequences for them. Because if we do define a well-known, I think we really need to consider those cases and see if there's any gotchas that we need to work around.
Sure. Yeah. I mean, okay, that's a reasonable argument. I don't know yet if I agree entirely, but I think it's a reasonable argument for sure. Yeah.
Alessandro Gadini,
Oh, hi.
Cloudflare. I just have a quick comment about the JSON description. The ports field descriptions talks about specifically TCP ports. Is there any reason why those need to be TCP ports and not say quick ports?
No, it just talks about ports because that's what I've implemented and that's what I used, and that's as far as we've got.
So
but,
yeah, it might be a bit more generic, I guess.
Sure.
Like the language.
Yeah. Okay, so I guess that's the plan, and we'll work on it.
That's good. We'll get the Git repository set up for you.
Great, thanks.
Yep. All right. Next, we have Sean to give the 447 biz update.
All right, exciting times, registries. Yeah, I know, exactly. Next slide, please. Just a quick refresher. We had an individual draft that we took to SAG to try to figure out what we wanted to do to change the recommended column, because that's really all this update is really about. And the consensus was to add a D, which basically is discouraged or weak. And so this 01 version of the working group draft is an attempt at trying to do that. So there might be some controversial selections here. Joe and I basically just threw them down to see what was going to happen. Also note, there are some other changes in this version which are trying to make it a little bit easier on IANA to be like, we changed these ones, we didn't change these other ones, to kind of make it a little clearer. This change has been a bit of a pain in the ass because there was new registrations, obviously, since 847 bis was written. So now I have to explain all those ones that are already covered. So it's kind of painful, but whatever. All right, next. So we did some minor updates to the references too. The first extension types value, we went through each registry of the TLS registry and said, what are we going to change? So the two that we came up with were truncated HMAC and connection ID. So we marked those as D. I'm just going to roll through these and people can jump up and scream and yell. The cipher suite registries, I'm hoping that all of most of these will be done by this obsolete KEX.
Well, I can put myself in the queue, but why is connection ID deprecated? We just registered like 30 minutes
So
ago.
there's two, right? There was one that was deprecated and then one that wasn't. So this is the one that's like, don't use this one. It's already been deprecated.
Oh, okay. Isn't that reserved?
It was marked as, I think it was marked as no before. So
Okay.
yeah,
I
but
think-
reserved
I
essentially
think
until
let's
it's 1.3.
distinguish the things which are valid code points, but we think are bad ideas, and things which are like not really valid code points anymore. And that seems like it's in the second category.
Yes. So, so again, so you think we should just make that N? Because there's a couple of those actually.
I think we should rename it to underscore capital reserved, and then make it N or D. I don't care.
Okay.
I think my position is all the reserved ones, like maybe we may need like another, it's like in a different this is in different categories. It's like this is like not even a valid code point anymore.
Well, because okay.
I mean, yeah, so market reserved, call it D. That'd be fine.
Okay.
Sean,
Yes.
my name is not Sean, but
Hi, Hannes.
the connection ID, because you write deprecated, does that refer to one of the connection ID values which we allocated before that, and it's used in deployments, and that's the one you want to refer to D, or you want to deprecate the whole connection ID thing,
There's
which
two
we just
connection
released as an
IDs. In
RFC?
the registry, one is connection ID deprecated. I mean, that's actually the string. That's the one that I want to get rid of. The one that's the right one that you guys actually deployed is the other value.
That's good to hear, because I almost fell off
Yeah,
the chair.
okay, no. Definitely not trying to pull the rug out from you. The cipher suite registry, I'm hoping that we're going to review that after we get through the deprecate obsolete KEX draft, because hopefully it's going to take them all out for us. Yay. Then there's some new ones, which was probably as a result of last time we did this draft, that there were some orphaned registries that were TLS 1.2 specific, and we were lazy and didn't address them. But TLS 1.2 is going to be around for a while, and now we've added this D. We figured we had to go through these. So here's another list of things, registries that are orphaned that we need to address. So next. So the first one, hash algorithms. I highlighted the ones in D just to show that they were different. I basically picked anything that was quote unquote weak. So MD5, SHA-1, SHA-224. And then for signature algorithms, made them N, went for anonymous, DSA, and then the GOST algorithms. Again, I'm just kind of waiting to see if anybody's going to jump up and throw something at me, but we thought these seemed pretty reasonable. All right, next. And then we have these certificate types. We basically just went through and said, obviously the Forteza one, we put D, and the ephemeral, the RSA ephemeral Diffie-Hellman reserve, we made those D. And then for the fixed, well, you can see them on the thing. So, all right, I'm glad to see no one is running up and trying to throw anything at me, but get to the mic.
What is the impact of removing the anonymous signature from the registry? Does it break the existing anon ciphers in TLS 1.2 in some sense?
That's the one that's back, right?
Yes, that one, the anonymous. What are we doing there?
So I think that was from a long time ago. What did we change that was?
I don't remember, but we're not, it's just being marked.
It's just being marked N, so it's still out there. If people are actually using it, then they can keep on using it.
I'm using anon ciphers. It's the default in postfix. Is prefer anon when neither side cares to authenticate anybody.
Right, okay. I can check into that one.
Sean, in the chat, Martin suggested both anonymous and RSA should both be marked as D.
Is D?
I mean, so this doesn't like break anything, but like, it's the position of the IETF that these are bad, and therefore it should say N. D, right? Yes.
So you think everything that's in the signature algorithm that's an N should be a D?
I didn't know. I think that the things in the signature algorithm that are bad should be a D, and things that are like meh should be an N. And so maybe RSA should, and so it's like I can see RSA being an N, but anonymous should be a D, as should DSA. I'm not going to fight you on RSA. Just like,
Ben Schwartz. SHA-224, nobody, is it broken? Is it just like weird? Maybe it should be N.
I did that once and then I made it D.
So
it's kind of.
Martin Thompson, I think the standard that we need to be applying here is that if there isn't an RFC that we can all get behind that says this is bad, then it shouldn't say D either. I think that's really the standard that I would prefer us to be applying here. So when it says D, it means that the IETF think this is bad. Now, I think that some of these are bad, and we should probably publish an RFC that says that. But I'd prefer that we at least make our position very, very clear in terms of what the rules are for when these get labeled this way.
no, I agree with you, and I suppose it should be this RFC. I propose this RFC and we'll add a paragraph saying anonymous is bad and DSA is bad, and then we'll mark them D.
All right. We can do
And
that. That's what this.
And I think that we say SHA-1 is bad and D5 is bad, and SHA-224 is, we think it's fine, but we don't think, but like it's not recommended, and so it's an N.
Okay.
Like, I guess, like my gloss of D is, we think this is bad and like quite likely is not like gonna like damage you if you use it, and you should not use it.
Okay.
As opposed to, it's just like some vanity thing that we don't care about.
All right. So let's go past this one. And then we have some open issues where we have elliptic curve related registries. And so one of the things was that we thought, hey, maybe we could put this in the deprecate obsolete kex drafts. But you know, these are the 6 registered values. Maybe we just stick it in our draft and figure out what we want to do with it. I didn't really know what to do with these. So
Need the first one.
right.
D, 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 D. Okay.
Yeah.
I
So
mean, like,
name.
the only ones anybody uses are like anybody should use and does use are uncompressed and named curve.
Great. And then all the other ones are just.
And
D.
like we know the other ones are like bad news.
All right. That's useful too. I figure we'll just put them in our draft unless the authors of the other draft want to arm wrestle
I'm not
over
like
it.
sure the compressor is really bad news, but like no one uses it, so like might as well be bad news.
So the reason that you don't want the other ones and you want them to be D is if you put them on the wire, things will explode, right? It's not that they're broken. It's not that they're fundamentally insecure. It's just that if you put them on the wire, things will break. And so we can actively discourage people from doing that. So let's do that.
All right. And I think that's it. I'll revise and move on, and I'll relinquish the rest of the time. So, cool. Oh, all right. Oh, I didn't notice. Yes.
Ben, you still in the queue?
Yeah. So about the explicit curve things, I believe they are broken to some extent. There's an attack by Nikos Mavrogianopoulos et al. That showed how to exploit them to do some damage. Just pointing that out.
Yeah, I agree. Explicit curves are like bad news. It was the compressed that I wasn't saying that were just the explicit curves definitely we should forbid, and the compressed are kind of like just nobody uses them, and as Martin says, it's going to make things blow up. So I think we're in agreement.
All right.
Okay, great. There we go.
All right. Thanks,
I
Sean.
think I'm next anyway.
Yeah. Yeah, Roger, next.
All right. Yeah, let me share the slides.
Okay.
All
Take it
right.
away.
Yeah, thanks. So my name is Nimrod Aviram. My co-author Karik Bartle is also here, and we would like to continue deprecating obsolete key exchange methods in TLS. This document, which is now a working group item, deprecates RSA key exchange and static finite field Diffie-Hellman, and limits finite field Diffie-Hellman in its ephemeral form only to reasonable groups with sufficient security. And it also discourages static elliptical-based Diffie-Hellman. During the last working group meeting at IETF 113, we were asked to verify that this document should fall under this working group, the TLS working group. And the chairs kindly checked with the security area director, Paul Wouters, and he confirmed that the document indeed belongs to this group. So thanks for raising this issue. Our aim with this presentation is to advance this document towards our working group last call. So the only open issue or issues we are aware of is regarding groups in FFDHE. Currently, the document safe lists several standardized and widely used groups. And there are also not standardized but widely used groups, such as the one that ships with postfix. And there's the question of whether the document should safe list them as well. And we are leaning towards yes, that it should safe list any widely used group that provides sufficient security. The other part of this issue is what happens when the client encounters a so-called bad group. So if the group is of an appropriate size, it is safe security-wise for the client to verify the group structure and proceed with the connection if the group is safe. We could add language to the document allowing that. However, performing this verification is computationally expensive. So if the client is unwilling to invest in performing this verification, or if we choose to disallow non-safe listed groups altogether, there's the question of what behavior the document should specify, whether the client must abort the connection in such circumstances, or that it merely should abort the connection. And that's it for us, from us. Let me say again that we hope to get this to working group last call. So if anyone has questions or comments, please chime in. Thanks. I see that Uri is in the queue. Yeah, please go ahead.
Yeah. There you go. Please go ahead.
I think the list is overly strict, the list of the algorithms to abolish, especially considering what implication move to or adding post-quantum stuff will have.
I'm sorry, you were breaking up at the beginning. Could you repeat that? My apologies.
That's okay. I said that, in my opinion, the set of algorithms to proscribe is unnecessarily strict, especially in view of the protocol logic that post-quantum algorithms will impose. I think I should stop here, at least for now.
All right. I'm not sure I got your intent, but we can take it to the list, or maybe if we have time during this session, we can you can continue. All right.
Certainly.
All right. Thanks.
Okay. Scott Fleur, Cisco Systems. Am I on mic? Okay. Scott Fleur, Cisco Systems. As for checking for the group structure, unless it's a safe crime, we do not pass enough information to check the group structure, and even a safe crime, it's not cheap. I would recommend just abolish just forbidding all anything other than a name group. Thank you.
Yeah. All right. Thanks.
Mike Ellsworth. This is not really a comment on your draft, but more of a rant. I'm a pen tester professionally, and in the last like 6 months, I've seen automated scanning tools are starting to freak out about like DH groups that are not random, or the DH groups that the tool knows about. And I've had banks ask me like, how do I generate my own DH params and put them in Tomcat? And I don't know where the tools got this idea or how we can like, but it's super frustrating, coming up like almost weekly at this point.
All right, thanks.
Hi, Victor Duchovny, Google. Thanks for singling out postfix, but I think it's far from the only one that has, built-in default groups. And even in postfix, depending on the version, you might see more than one. It changed in 3.7 release. So I don't know whether it's possible to whack them all the safe, but not a priori known built-in groups in various products. That seems like a difficult challenge to keep track of them all.
I see, thanks. I think Ben Kadok wanted to speak. He's online. Yeah. Hi.
Yeah, Ben Kadok back, and a nice segue from Victor's comment, which is just me sort of spitballing, brainstorming on the fly here. But what would we get enough if we went and made it easy to register new named groups for these things that are already widely deployed, such as what postfix has or anything else? Like, would that get us enough enough properties that we would be able to leverage that for the purposes of this document?
I'm not sure I got the question.
Well, so like we have some widely deployed groups that are not like the specific well-known named groups that are currently in our infrastructure. And so we could say, okay, well, we know what these are, they're safe, let's name them. And now we have named groups that we could treat on a more even footing to the other things that we have. But I don't remember the details of whether that's actually quite enough for this purpose. So it's not necessarily a question for you as much as to the room.
Yeah, all right, thanks. I'm not sure how that would work, to be honest. I'm not familiar enough with the details. Thanks.
This is Daniel Kahn Gilmore from the ACLU. Sorry, I failed to get in the queue electronically. I wanted to reflect on the pen testing comment and where that idea comes from, right? So the concern is if you have a known group, then some adversary can do a pre-computation-based attack against the known groups. Therefore, it feels safer to do an arbitrary group. In practice, in the whole ecosystem, given that you can't, as a client, tell whether that's a known group or not, that's not safe, right? Because you could be attacked by the server that you're talking to who's just giving you bad groups, or somebody could have misgenerated a group. So there's a lot to be said for us as a standards organization to say that we think that approach of choosing random groups is a bad idea. But that's not going to stop people who are afraid of pre-computation attacks by a powerful adversary against named groups from raising the same kinds of concerns that you talked about. So maybe what the specification needs to do is say, unless there was a known pre-agreement with the with the peer that you're talking with, right? I don't believe anybody here actually thinks that it's wrong for a private organization to use their own groups that they've done their own verification on, that they could list, right? I'm not recommending people do that, but the pushback that you're going to get from these pen testing tools we need to be able to say this pushback is wrong, and here's why, and here's a statement that understands why the pen testing tools thought they had the right idea. We need to acknowledge that concern so that we can actually get them to stop making these requests, right? And so I don't know, I'm not sure exactly the right way to do that in this wording. I like Ben's suggestion of like, let's have a registry that people can put, widely distributed groups in that actually have been checked. But I'm very reluctant to, like, I don't think just the fact that we say, hey, don't use anything like this will fix this pen testing tool complaint problem. I think we need to address it head on.
Yeah, let me add that I think all of these groups are kind of on their way out. So this is finite field DFM, and people are like in the process of switching to ECDH, I would hope. But sure. Thanks. Yeah, please go ahead, Martin.
Yeah, Martin Thompson. The discussion in chat here is kind of interesting. I think that there's several of us who sort of realize that in TLS1.2 and earlier, using the FFDHE groups, which only specify the one value essentially, which doesn't let you do the validation as Scott points out. The only way that you can do that safely is to have a list of values that you would accept. And I've implemented that with the 7919 groups. And we just can't turn that on because in practice people use other ones. And ultimately we concluded that the only safe way to do this was to turn off FFDHE in TLS1.2. And you can do it in 1.3 because you have the named groups, but we couldn't turn it 7919 on for TLS 1.2 because it was just impractical. And then with people going off and generating their own groups, you've got no way of knowing that they're okay a priori. So this is exactly the point that DKG made. If you've got your own private agreement, that's great, but you can also have your own private protocol at that point. So we're not adding a lot of value here. I tend to agree with David Benjamin, which is just a flat prohibition on the use of FFDHE in TLS 1.2 would be the most sensible thing to do here.
That would be a major revision to the document, but sure, we can do that as well. Thanks. Yeah. Uri, I hope I'm pronouncing your name right. You're in the queue. Please go ahead.
Yes, you are. And I wanted to agree with the previous speaker and say that, in my opinion, we should neither recommend nor prescribe use of those, how do I call it, special groups. If user organization believes that it knows enough about them, it is not our job to tell them otherwise. Besides, in all likelihood, they do know enough. Thank you.
Sorry, could you repeat that last part of the sentence?
I said, in all likelihood, if they turn to that solution, they probably do know enough to use it. It's not out of ignorance that they made that choice.
All right, thanks. Any other questions or comments? All right, so I guess I will try to summarize the points that everyone brought up and take it to the list. Thanks.
All right, thanks, Nimrod. Now we'll move into the individual draft presentations, starting with the SVCB validation request for details 1.3.
Hi, my name is Rob Seegers. I'm with the FAA. Next slide, please. So in global aviation, we are defining a trust framework to be able to use PKI and to harmonize and map commercial aviation identities and access requirements to a common set of operating rules, something that may seem very common within the internet and within even some examples of the US Federal Bridge, but it's never been done so far in aviation. And we have been using something that has not been used very much, which is the server-based certificate validation protocol, and to validate trust and identity. Because one of the challenges in aviation is that you have a lot of different organizations that are not centralized. You have ICAO that operate on a principle of state sovereignty, and the software is quite often custom and developed, owned, and operated and managed independently. So there's no easy way to say I can, sent out trust list with my software updates to the different entities. And then, like with SSL on the web, you can trust who I am when you connect to me. So the interoperability is key, and we have to use standardized protocols. Next slide, please. So aviation traditionally has been using a lot of custom protocols, and we're moving away from that. And I have an agreement with ICAO Communication Panel, AirInc 858 for avionics, and also with RTCA Subcommittee 223 for air-to-ground communication, that if we can get this to an IETF standard, that they are adopting this as part of their implementation of the IP services for aviation. And we are moving from real old ACARs via Europe having used OSI to now IP services, which is a really big step for aviation. And using trust lists and CRLs for this purpose is very difficult because you have a lot of entities, flying entities, aircraft, with different commercial airlines that all have to communicate via data communications with different air navigation service providers in 193 countries and the airlines. So you can see it becomes a big maintenance problem for the aircraft itself in that case, even if you use short-lived certificates. And so ground certification validation on the aircraft using SCV validation basically would only require a very small one or a few trust anchors that don't change. And we are proposing a new SCVP validation extension to remove the burden of the SCVP requests from the aircraft client, and having the ground server making the SCVP request provide the result to the client, and therefore also reducing the complexity and the cost of avionics software to have to calculate the trust path. And I'm handing it over to Ashley. Next slide.
Hi, I'm Ashley Kopman. Oh, is this too tall? Sorry, is that better? Okay. I'm Ashley Kopman. So this shows a diagram of how, I'm still not close enough. Okay, is that better? All right. Is that better? All right, sorry, I don't speak loudly to start with. Okay, so this shows a diagram of how it could be used in aviation. So in our case, the aircraft is the DTLS client. When it sends down the hello message to the ground system, it would include with it this new DTLS extension of SCVP validation request and a structure which optionally includes a list of the SCVP responders that it trusts. If it does not include any, then it insinuates that it's explicitly known by the ground system which SCVP responders the aircraft trusts. It also can optionally send down a list of trust anchors. If it includes the trust anchors, then the certificate path has to terminate at one of those trust anchors. If not, it is because the SCVP server has been pre-configured with the trust anchor with which to terminate the path. And finally, it optionally can include SCVP request settings. So we've defined a few of these, and I'll show those later. But the idea is to keep those request settings small, to keep the request size down, and only to include a minimum of what you need to optimize the request for the aircraft. When the ground system receives that validation request, it optionally can have a cache. It's suggested to have a cache. And if there is a matching value in the cache, to return that up. If not, to translate that validation request into an SCV CV request object and send it to the SCVP server and receive back the response from that server. The response is signed by the trusted SCVP server, so it can be trusted by the aircraft. and it is sent back up to the aircraft with the certificate of the server. Next slide, please. All right, so this shows it in a simplified handshake diagram. So you can see there's very little changes to the actual handshakes. It's an extension on the client hello message, a validation request. For this message, we have defined it for type SCVP, but have allowed it to be expanded to other validation protocols as well for future use. And then the SCVP CV request and CV response is existing. That's not new. It's new to incorporate it into the TLS server. And then there's a new extension to the certificate message of validation request with the path validation information. Again, it's defined for type SCVP and would include that CV response back to the aircraft, or in this case, back to the TLS client. So for the SCVP validation request type, there is a mapping of those extensions that I mentioned earlier between the path validation request message and the CV request message that's defined in the RFC as well, or in the proposal as well. And yeah, I think that pretty much covers. I feel like I talked really fast. There's got to be some questions.
Oh, okay. I see. All right. Yeah. Any questions? We'll do the question. Yeah, Ben, go ahead.
Hi, Ben Kaduk. So I guess the TLS part of this seems to make a lot of sense. It's pretty straightforward and seems clearly reasonable. I'm less sure if we are proposing or saying that we need to additionally specify the sort of right-hand column on this exchange on the current slide where the TLS server goes to the SCVP responder. Does that exist already?
So not from the TLS server. So the protocol, the SCVP protocol exists today. It would be adding that functionality to the TLS server to make the call and receive the response.
But that's more a matter of coding in the server than it is like defining the protocol, I guess is my question.
So there is a mapping from the request message coming from the client to the request going to the SCVP server that's defined in the proposal. And then there are certain values that are only known to the server that need to be checked in the response coming back to verify that the response is valid before passing it up to the aircraft. And those are
Okay,
also
so there's a bit more work to do. Okay, thanks.
Yuri?
Do you have any concern that using a full-blown DTLS could introduce an unnecessary expense on a cipher suite negotiation and such?
You want to take that, Rob?
In my experience, using or being in constrained environment, we decided not to use DTLS because we did not need that much of flexibility and negotiation, but we cared very much about bits that have to cross the air. Do you have similar concerns?
Yes, Yuri. This is Rob Seegers responding. So SC223, the air ground subcommittee from RTCA, has profiled the DTLS protocol down to what they exactly need and to ensure that that doesn't become an issue. And I was actually very interested to hear about the compressed TLS, because that may be actually an option to further encode that. So thank you.
Hi, this is Hannes. This is sort of more in response to Uri, because this topic comes up regularly. We've gone through this numerous times in the meanwhile on the question of like, is DTLS something that you can use on IoT devices? And the answer is, look at the papers, look at the documents. We've done the profile. It's deployed in millions of devices. Even DLS is deployed in millions of IoT devices. So like this topic has been answered. So there's, as you said, like if you don't send everything you have over the air for no good reason, then you are completely fine.
Hi, Eric.
I just want to quickly add here that IoT can have different constraints. There is a computational constraint, and there is bandwidth constraint.
Right. I
I was
believe-
talking about the second.
I believe Hannes was talking about all of these. He does work on IoT devices. Eric Pasquale, I just want to see if I can sharpen Ben's point a little bit to make sure I understand. As I understand it, this is an entirely stock SCVP server on the right, correct? Good. Okay. So this seems quite reasonable. We talked on email, I think, a little bit. I guess my question is, what do you want? Do you want this adopted by the working group? Do you just want us to give you a code point? What are you hoping for here?
We would like the help from the working group to get this to a standard. We invite everyone to review and comment and to make sure it's a good approach.
Okay, so it sounds like you're asking for working group adoption.
Yes, please.
I guess so. I'm sort of provisionally in favor of that. I guess my one question would be, we often have situations where an external body wants us to do something, and where we have like a very thin kind of like relationship with them with like a couple people. Are you the people we're talking to, or are there other people that sort of show up and help us out? Because like
there will the plan was going forward to get Airbus, Boeing, Collins involved.
Fantastic. I just want to make sure we actually capture the entire space. Thank you very much.
That's correct.
Bob Moskowitz. Rob Seegers has pulled me into this fun and games, and so I can answer that. Yes, the people at the table are the airframe manufacturers, the other national CAAs, the airline industry. A number of the players are there at the table, and how they're going to do this, because they realize they have a serious issue they need to address. I feel the players are there. They are dedicated to get this done. They do have a reasonable time frame, because it does take time to make the changes, but they do want to get into their proof of concept, so they have a commitment going forward. Yes, there are changes on the TLS server side, that it has to now support this particular extension, but the number of those servers which are around the world is a manageable number. And again, the parties that own these things at the national airports and so forth, we have enough of them, I think, committed, that the rest will then follow along. The big players are committed, and the rest will participate. So I think you have the community of interest for this, and it's worth the work group putting their knowledge behind to make sure this is done right, because this has international consequences if it's not done right. Thank you.
All right, thank you. Can we get just a quick show of hands for folks in the room who have read the draft? All right. Not a whole lot, but there's probably some more online. We'll convene amongst yourselves and take it to the list, I think. Thank you so much. All right, Hannes, I think you're next.
Okay, some of you may have been at the Hot RC event yesterday, and where I talked about this new work. Now I focus more on the TLS related part and go a little bit more into details. This is obviously new, so nowhere close to anything asking for adoption more figuring out whether any one of you is interested in that type of activity. As you know, I work for ARM, was previously mentioned. In my side of the industry, there's a lot of excitement in defining new hardware extension for coming up with new forms of isolation, which then obviously bubble up in operating systems. And also demonstrating that you have these hardware capabilities and these isolation capabilities to other parties, and that happens in form of attestation. Okay, next slide. So we have, since there's a couple of or various projects ongoing, if you look at the Confidential Computing Consortium, you see where some of those, or how some of those activities look like that utilize these new forms of software isolation. You see that there are various different ways to communicate attestation information from the device out to whatever type of relying party. And so we are trying to make an attempt to generalize the solution a little bit to avoid having everyone come up with their own technique, which is doing more or less the same. And what many of those mechanisms do is they stuff something into DLS for fairly obvious reasons, because you have to establish a DLS connection very early in the interaction anyway. And so what we wanted to do is we wanted to, taking the work of RATS, support their two models. If you don't know what the background check and a passport model is, there's a good architecture document in the RATS group explaining it. And we also wanted to support different attestation formats or attestation technologies like DPMs and some of the stuff we have come up with in ARM with the entity attestation token. And also we wanted to be agnostic to the DE technology, the underlying DE technology, whether that's our most recent architecture called ARMv9 or older things, which you guys are all using in your phones, in your tablets, and big thanks being loyal customers. Next slide. And technically, it sounded like at the beginning very simple. We obviously need to add an extension for the negotiation of this new feature, straightforward. We wanted to use the certificate types because we are conveying the attestation information in the certificate payload, but unfortunately we had to stuff in a new field, nonce, which is used for freshness of the produced attestation information. So that sort of made the reuse a little bit more complicated. And obviously, as I said, the content in the certificate message is then changed. What it actually, I'll explain on the next slide what this content of the certificate message is. But in many cases, the attestation information that is produced by the hardware or by software hardware combination is something like, I linked an example in case of what we do. It's called the ARM Platform Security Architecture Initial Attestation Token, some fancy name that our marketing people came up with. And that sort of captures what the hardware is and also what the state, the initial state at the boot time, the software actually, what it compromises, what the different components are. Quite useful information, obviously. But for the DLS exchange, you need more than just having that token, which you could describe as a bearer token. You need a key associated with it, which many of those attestation technologies today that are out in the field don't provide. And so we had to augment that a little bit. And on the next slide, you see how we did that. Nothing super fancy, but still worthwhile to talk about. Also obviously described in the document. So here's an instantiation of how this looks like in a typical scenario. So the device is split into, in this case, into two parts, which is like the part where the Linux runs, one sort of compartment, and another one, which is here called the secure world, which runs something like OptE as an operating system. So there are different operating systems running at the same time in different software isolation containers. And if the DLS stack is in running in Linux as an application, and then sort of communicates with this secure world side with where an attestation service is, and that talks to a specific in this case, a security engine like a DPM or something else, to get the attestation information, and then it bubbles up. But as I said, that token by itself won't do the job, so there's another layer needed where the device at some point in time generates a public-private key pair and produces an attestation, a key I called it a key attestation token, which is conceptually, you could think of it as a CBOR web token with a proof of possession key that is then used in the TLS handshake to actually demonstrate the possession of the private key. And that happens, that is generated inside this, the secure world. So it's a little bit more nuanced, but sticking together a couple of IETF technologies in the end. In the DPM case, there's also some W3C attestation format involved as well, because they use their own sort of technique. Eka, you have a question?
Yeah. So you're probably gonna tell me there's some internal reason why this won't work, which I'm willing to accept. But is there one key or two keys? Like, does this look like TLS client auth, or does it look like with a funny certificate attached to it, or does it look like something else?
So there's one key. Well, there's one key, a separate key to sign the attestation information, the initial platform attestation token.
Yeah.
And then there's another key that is used for the TLS client authentication.
Right. And so is this just a new certificate type fundamentally?
Fundamentally, yes.
Okay.
I just couldn't use the same payload or extension because I had to put the nonce in there, and there was in the original certificate type extension, there was no place to put the nonce.
Because the nonce comes from the verifier?
Yes. It comes from the verifier through the so that's why there are these two types of models in RADs. So in the background check model, the nonce comes, in all cases, it comes from the verifier, but in the background check model, it then gets channeled over the TLS exchange, the TLS handshake.
Right. I'm just trying to figure out if there's some way to sort of like cheat this into the TLS a little more closely. But I'll read the draft and see if I mean, if we have to do some other thing, I understand. But I'm just trying to like do it a little more possible.
In fact, we're also trying to figure out on how to best fill this in, and that's why we are sort of soliciting feedback from those who work in a similar area.
Okay, we have online from Pingling.
Okay.
Thank you. Hi. I have a question. First of all, I think this draft is very useful when we use this in the trust execution environment and to the client. But I have a question: is that is this protocol only support the EAT and the TPM attestation? If is this protocol support other attestation? For example, if there is a measurement result or just a hash value, does this protocol will support that?
Yeah, so we wanted to support different attestation formats. To begin with, we wanted to focus on the sort of like the TPM and the EAT-based approach, and like I don't see a reason why others couldn't be included in there. So the part that goes into the TLS exchange doesn't actually care much about what it is, but for the overall functionality, obviously it matters how you stick the different pieces together.
Yeah, I think we could clear that this protocol will support the other measurement format because I think that will be more wide range of this protocol.
Well, we probably should try it out. So so our plan is to contribute this or to contribute the project, the software to the confidential the software to the confidential computing consortium to actually have others to look into that as well. So maybe we can work together on that.
Okay. Let's talk in mailing list. Yeah.
Good. Thank you.
Daniel Kahn-Gilmore, ACLU. So let me just ask a couple questions here. Is this just the client authenticating, or are you envisioning this being symmetric within TLS?
Actually, it's both. And in this simplifying example, I just focused on the client, and the code initially focused on the client. But it turns out that you also want the server attesting to the client. For example, if you have some confidential workloads in some cloud-based service, you also want to know whether you're actually uploading your code or whatever to the hardware you're expecting it to be.
Yeah. So thank you. That's useful to understand. My second question is about the persistence of the platform state and how this can be used. Like, what are the ways that this could be anonymized so that, for example, two separate processes that run on the same machine don't end up identifying themselves as being co-tenants? Or if a user, say, wants to clear their state and come up with a new identity, it doesn't, then the platform state doesn't itself leak a linkable identifier to the server over time. Is this question something that this is grappling with? I apologize, I have not read the draft in detail. I don't know I don't know the specifics.
That's a very good question. And I think this is on the to-do list. Obviously, like you, Monty, for DPM and for some of the attestation technology. So there are two pieces to your answer. One is, how does the attestation technology avoid providing identifiable information across different interactions? The other one is there's some additional information, this what I loosely referred as key attestation token here, that could also identify you or provide some linkability. And that's obviously also a concern. So definitely needs to be answered and written up. 0.0 draft, lots of things open.
Okay, thank you.
Yeah, so I think a lot of these are a bunch of to-do things, which, I'm going to be involved in, obviously. Monty Weissman, by the way, beyond identity. The other, there's two reasons for the attestation key not being a thing to sign. One is the nonce, but the other reason is, in order to be of any value, the attestation key has to have the properties of only signing things that are inside the TPM. Otherwise, you can hand it a blob and say, here, sign this. It'll become a signing fool, right? So it cannot sign external data. It can only sign stuff that's inside the TPM.
Exactly.
So that's another important reason why you can't use the attestation key. The other thing that I think we need to start thinking about is there's lots of aspects of the platform. Do you only care about the BIOS, the firmware? Do you only care about the OS? Do you care about IMA? Yep. We have to be able to hand it a bunch of stuff that's, here's the stuff I care about, and then get this back. So I think this is going to be a more complicated thing than I think it's a valuable thing to do, don't get me wrong, but I think this is going to be a lot of work, and I'll be happy to be involved.
Excellent.
Okay, I think Nick online.
Hi, Nick Doty, Center for Democracy and Technology. Thanks for presenting this work. I have some of those same privacy concerns that have already come up, and I see, yes, it's an early draft. The privacy consideration section is not written. I expect it will be a very extensive section, and I certainly would encourage you to consider that early on, because I think it could have very fundamental implications for the design of the architecture altogether. One question that is coming to mind as I look at this is why, I think you even note this, this could happen in lots of different layers. Why should this happen in TLS? Like, I'm still learning about this area, but it seems like most of the sort of fraud cases that we're worried about are very application specific. If you're doing a different type of thing, you're going to need a different type of attestation information. It's going to be specific to what action the user has taken or other criteria. It seems like setting that up in just securing the communication end to end seems like kind of an odd time to do that. You don't have any of that application specific information. So why should this be a TLS layer protocol rather than an application layer?
Hey, Nick, haven't seen you for a while. That's a good question as well. I've been also wondering of why the TLS working group would be a good place, whether maybe RATS would be a better place or maybe some totally different group. I don't see a concern with the application-specific information because that's not really something that's sort of more policy what to include and what not. But there's obviously a TLS extension that needs to be defined here and described, similar to the certificate types extension, which described on what type of certificate to put in there. And in some sense, from a TLS point of view, there's little to do practically. Like, it's actually a short document. The problem is I have to set the context also here in the presentation, like otherwise you don't know what I'm talking about. And that's the difficulty. And I don't know how to best deal with that, whether it's actually better to put that into 2 documents or one that is more like the architectural aspect to it, which already RADS does in some sense. So lots of it, what I'm talking about is in RADS. So I don't know. Appreciate guidance here. Having been in the IETF for a while already, I should probably know better, but yeah.
Well, maybe just to continue that a little bit, like why does the user want to do it in the setting up of the connection rather than attesting to themselves once they know some more about what they're trying to do with this server?
Okay, yeah, the use case. So actually, maybe it would be best for me to distribute one of the confidential computing consortium use case or their white papers, because they describe some of the use cases on why you would want to have attestation and some of those software isolation techniques in general. I think there's, for example, you want to upload code onto a cloud-based infrastructure and run it there, but you only want to disclose the code and the configuration data to certain platforms that meet certain criteria. So they can, for example, to run the code there, that even the cloud provider doesn't see what you're running. That is one of that's sort of the promise of confidential computing. And so, for example, you may have some machine learning data in there that you don't want to spread around, that you want to keep yourself. That is one of the use cases in confidential computing. So in general, like pushing code around and making sure that it's actually, you run it in an environment that is what you would expect. For example, moving workloads from the cloud to the edge and running it there, including obviously data that this code would run on. You want to make sure that you actually store it on servers that meet certain criteria so that the data doesn't leak out into the wild. Because otherwise anyone could sort of like claim that, oh, I'm running a virtual machine here with some great hardware. I'm really protecting your data, but in fact, it's not happening. I hope that makes sense.
Yeah, I mean, the server, those server cases would also have less of the catastrophic privacy concerns that some of us might have. So yeah, maybe that would be a more promising direction rather than users having to attest to, I'm not even quite sure everything about their device and potentially hard linkable certificates or keys. Those other use cases might make more sense or make that easier to understand.
I will post the white paper to the list on what the confidential computing consortium believes that is useful areas.
Okay, Hank?
Yeah, sorry, I'm Hank. So I know this is a 0-0 draft, and I assume you're creating evidence. It says there, but I don't know what this evidence is about, and I would never understand as a remote peer client that I want to initiate something. I create the evidence. What would I put in there? So there you say EAT or TPM, so I have some understanding. So that has to be fleshed out. But this is 0-0, I get this. But evidence is never set to a lying party, which is literally what you say. And so then there's a verifier in the picture and attestation service, which are also, so that I get the point we want to solve. But yeah, so this really has to, Thomas is on this draft, so that makes me confident that this will be sorted out.
Sounds great.
Yeah, at the moment it looks a little bit all over the place, and I would never know what is where. And never use the term attestation, by the way. It's bad.
It's Yeah, the challenge is in RADs, the different flows or different patterns, information patterns, and depending on which pattern you look at, the information is called differently. But I would like to stuff it in there.
The information is always called the same. They're just in different sequences transported. That's so I meant to make that clear. And also talking about evidence and attestation results would resolve all the problems, I think. Just label those, differentiate them. I think that will make everything very clear. And then you're basically halfway there.
I will give it the Hank sort of brush next with 01.
All right, thank you, Hannes. Next up, we have a update on the post-quantum process from Sophie and Tom. Tom, are you going to share slides?
We shared the slides with the chairs, but if you don't have them, oh, there you go. Oh, thank you.
Great. Okay, I can see the slides now, so we can get started. So this is a very brief, very abbreviated talk just to get the ball rolling on PQC again, because some stuff happened. So let's go to the next slide. We're presenting somewhat of an overview, but it's definitely not complete. We're going to briefly touch KEX, key exchange, but that has been talked about a lot already. So, and we're just trying to present a neutral overview here. Although we are obviously also authors of a draft, it's not about that. It's just about this is what has come out of NIST so far, and it's probably something that we're going to have to deal with now. So, next slide.
Okay. I think
Am I on the right slide?
I think Tom got frozen, sorry, but I can take it. So yes, you're on the right slide. So basically, as Tom already said, we're not going to focus specifically too much about the key exchange part of TLS 1.3, because that's indeed, there's a way to actually easily add the post-quantum algorithm, and seems to that every of the experiments that have been run, all of the academic papers related to it, seems to show that indeed it's easy to just swap the classical algorithm for a post-quantum one. For a while, it will be good, as it has been recommended by the hybrid design document, to actually not only use the post-quantum algorithm in isolation, but rather to combine it with a classical algorithm for the time being. Next slide, please. The part that is a little bit more complicated, it seems, is the one for authentication in TLS 1.3. And the reason being is because at least the algorithms that now have been selected for standardization by the first milestone of the NIST process seem to have sizes or computational times that are bigger when compared with the classical counterparts. Of course, authentication in TLS, as I'm sure that everybody on this group knows, could happen in different ways. But in this case, next slide, please. We're talking about certificate-based authentication. Next slide, please. Okay, and as you know, there's many signatures and verification operations that are actually happening as part of the TLS session. It's not only about the handshake signature, but also all of the related ones. In general terms about the handshake signature, it does seem that at least some of the experiments that I have run, it seems that it would be okay-ish to swap the classical algorithm for a post-quantum one, and that should be okay. But as we know, the signature algorithms are not only the handshake signature, so all of the other ones that are related to the TLS session itself seem to be more cumbersome to actually migrate to post-quantum cryptography. I'm not sure if Tom, you're back.
I hope so.
Okay, there you are.
Great. Let's hope the Wi-Fi holds up. Yeah, we can go to the next slide. So this is all the new schemes and some of the things that's out there already on one slide. So for comparison, we have the pre-quantum stuff. And if you then look at the lithium-2, so that's the smallest larger, right? Fortunately, in terms of computation, it's quite a bit faster than, say, P256, but yeah, it's not small. If you put that everywhere, it's probably going to be difficult. Falcon, on the other hand, is nice and relatively small, but it's worth pointing out here that the if implemented correctly here is a direct quote from NIST's selection blurb that Falcon is quite tricky to implement correctly. We talked about that a bit before in the CFRG talk earlier today. Then we have Sphinx Plus, which is hash-based, slow but conservative, and it's worth also pointing out here something. Those are stateful hash-based schemes, so they might be useful for maybe fit for general purpose, and that is also something where it seems like the theme here is we have all sorts of trade-offs. Certain things are fit for certain purposes, other things are probably fit for other. Yeah, that is the name of the game here, probably. There is going to be an on-ramp. We also talked about this previously in the CFRG, where NIST is calling for new signature schemes. But the scheme that I think is most likely to go into that process is UOV, a queue-based scheme. But 400K for a public key is really, really quite big. Although then the plus side will be that the signatures are going to be very tiny. So maybe CAs.
Okay, so if you're ever interested actually into checking how post-quantum cryptography deals into the networks, there's different experiments that have been run by Google and also by Cloudflare. Specifically, and most of the times these experiments have been run and have been focused on the key exchange plot, as I already said, and there has been really few ones focusing on the authentication. So this is also a call for anybody who is interested to actually run more authentication experiments with post-quantum cryptography. Note also that OpenSSH in the version 8.9, sorry, uses Entropy Prime as the default key exchange algorithm. Next slide, please. There's also, as I said already, some academic studies. In this case, it's more constraints the results because most of the times they are running on simulated networks. And this is in the only sense, it's the only academic papers that exist around password-based authentication only come from the academia. So there has been almost no actual working items around that area. So if you're interested, please check these links. Next slide, please. And
yeah.
Okay, there you go.
Yeah. So I just put a bunch of the stuff that I could find if I type PQ into the data tracker. So it's very for limited use cases, probably. Lamps is really working very hard on the whole PQ topic right now, it seems. And of course, we have the hybrid. Worth mentioning is also the PQC mailing list, which I think opened recently, and Flow recently sent off a draft around there, which aims to resolve the whole what is hybrid versus transitional versus composite, and try to resolve that language, which I think is very cool. And I think that's going to set this batch, so you might want to look out for that thing as well. And we can talk about questions. That's okay.
Questions? Oh, sorry, go ahead, Tom. Corey, go ahead.
I just want to express support for this effort and hope that it will proceed on the standards track.
Any other questions? Oh, someone's getting up. Scott, go ahead.
Okay, Scott Fleur, Cisco Systems. One minor nit, you are using the round 2 Sphinx Plus parameter sets. Round 3 is slightly smaller. I don't know if it's enough to make a difference.
Then I think Bas might have corrected us in the wrong direction.
No, I'm not sure actually, but we will check that. And if indeed they are wrong, we will update the slides. The ones that we corrected were from CFRG, but we will check it. Scott, thank you.
Anywho, this is not very authoritative.
Ed, go ahead.
Hi. I was wondering if you've done the arithmetic on how many bytes we're talking about and whether we're likely to run into any length limits in TLS. So things like, you know, there's a limit of 16 megabytes, I think, for each certificate, for each handshake message, or maybe more practically, there's a limit in how many packets can be sent in the first flight of a quick connection, which limits the size of quick initials. I wonder if, you know, how far are we from those limits with these algorithms?
I'll take this one. So for starters, there's the Bas Westerbaan wrote a nice article on Cloudflare to drag over the internet if you just, for example, put the lithium somewhere and how much latency that imposes, which was a experiments with post-quantum stuff in TLS and while implementing that for the more ridiculous schemes out there, I found that common for implementations to have a comment in their parser and one parser that says, oh yeah, no it's ever going to send that, so bye. And that kind of stuff is implicit, but definitely present. So that might be a challenge going forward. Quick has the anti-amplification thing that you can only send back 3 times the initial message. And this will likely mean that you need to do padding of the initial message, or perhaps even initial messages, such that the server can actually send back the certificate chain if it goes to a certain size. Talked about this a little bit. I think they also have an issue on their interoperability checker to also actually check if this works, but I just looked at a few documents one time to see if it was interesting for research, but it seems they have thought about it a bit at least.
Yeah, the quick working group does have it. I'm not sure if they have updated it, but they were planning at some point doing a hackathon to actually check it. But Lucas Padu might not know more updated versions of that. There has not been a formal study of the different sizes. I know it has happened for DNSSEC because there's a very interesting paper by Roland von Gijs van Dijk, but not specifically to a TLS. So maybe that's something that can be looked into a bit now.
Thank you.
Eric Pasquarella. So it's probably worth distinguishing the network dynamics from the implementation issues. So, I mean, I agree there probably are implementations which are sad if you send them 1 megabyte certs, but the implementation would have to advertise that they spoke post-quantum anyway, and you could just not do that if you haven't figured out how to fix the giant message problem on the receiver side. So I don't think that's a big deal. I think the bigger deal is around trip time and like the size of the initial flights and whatever. And so once you get outside like IW10, things start to get pretty terrifying, even if you have anti-amplification techniques. Because you just can't you can't just dump 50 packets on the wire like under basic anti conditions. And remember, the quick anti-amplification is about avoiding having to establish the round trip time. And I think practically, like, I mean, I'm not sure. David Ben's not here, I don't think, but I think the general sense is like once you get about 10 kilobytes for like the certificate payload, like people start to get pretty sad about the whole thing. And straight TLS, and it's not because of the implementation, it's because of the TCP dynamics. So I was looking at this and being like, this is all pretty horrifying. And so I think the good news is like, it's all in the future, but like it's all pretty horrifying. MT can speak for the quick work review.
Yeah, there's something there that maybe there will be hope of something coming that it has some smaller sizes. So I mean, in the CFRG presentation, we do talk about that there's going to be a new call for algorithm proposals with signatures. So maybe there will be something as smallish coming, but I don't think I don't think elliptic curve cryptography is small.
Yeah, so Martin Thompson, there's a bunch of things that we're going to need to work through with Quick, because one of the things that concerns me here is that even just trying to put Kyber in the first message is going to overflow that one with, there's not a lot of extra space there when we talk about maybe a 1300 byte packet, and then you've got to put a Kyber key exchange in there, and you basically used it all up at that point. At the point that you have to send 2 packets, that's a major problem for the client. Hello. If we can get it into 1 packet, that would be great. That means potentially, basically that just means I'm really sad about the points that NIST has managed to decide are appropriate for the security levels that they're targeting. I would probably be happy with a slightly lesser security target in order to fit it in the damn packets, because the performance is going to tank badly. As far as anti-amplification goes, I think that's much less of a pressing concern, because the client can send a few extra packets if it knows that the client needs to send a lot more. And if they're not critical, then if they get lost, it's not a big deal. But if they are critical and you're putting the key exchange in multiple packets, then it becomes a problem. As Eka said, 10K is probably, we might be able to push it over 10K for something like Quick where it's relatively new, but I don't imagine that there's going to be very many people who are happy if it's many tens of Ks, or the 400K thing is just a non-starter. So we'll have to get creative with compression and things like that when it comes to that. I can confirm that all of the stacks are fine if you send a very large client hello, but the performance is going to be terrible.
Yeah, I completely agree. And one of the things is that during the NIST standardization process, there were some academic papers and some experiments about what could fit into the networks or not, but not much that many information as compared with other things that the NIST process focused on. So if you're actually interested on NIST to hear on these, my recommendation would be to actually attending either the NIST workshop that is going to be happening on November, and actually putting together what will be real considerations from networks and protocols. We're also running an event which is called PQNet, and I will put it later on the Sulip chat, in which we talk about post-quantum and network protocols, and this time is probably going to be co-located with the NIST workshop on November. So if you're ever interested in actually talking about these concerns and making this reach the NIST ears, maybe that is also the place.
Can I just one thing to point out that we missed in that one, and Scott's distracted me, so I've largely lost the thread. I'll carry it on chat.
Okay.
Yes. I apologize. I just thought of it as I walked away. If you send a message in 2 packets to a server, those servers that are doing stateless processing will likely tell you to go away and come back again later. And that's going to add a round trip to everything. And I can see, yes, she's saying that's a major, major problem.
Okay, that's fine. All right, thank you, Sophie and Tom. We pushed one agenda item to the end. That was the outstanding issue on the TLS flags draft. You is here. Having technical difficulties up here, so we can't pull up the PR, but we can probably just speak to it if that's okay.
So the one question that remained was, is it possible with the TLS flag extension to define a flag that the request, saying the client hello, is just that one flag bit, but the response is going to be a real response and a real extension with actual content rather than just, yeah, I support this. So the client says, well, it could be the other way around with the reverse thing, but so say the client says, I support this, and then the service says, okay, so here's a whole bunch of information. And the question was, is this a legitimate use? And well, so I wrote a PR that says, no, you can't do that. And we asked for comments, and we got pretty much nothing until today, when we got something kind of non-committal from Ecker and Martin. So either way, we can have it with this PR or without this PR, but I think it's time to close out this.
The text is in the chat.
Okay,
thank
good.
you, Sean. Ecker, go ahead.
So, I mean, I agree this PR is clear, and this PR clearly says you can't do it. My view, I think, is you should be able to do it, because I think of sending it as, I think of sending the bit as sending the extension. I think Martin thinks of sending the extension as sending the extension. You know, I think, you know, I'm not going to like lie down on the floor over this, but I think Martin isn't either. So I guess, like, is there anybody else have an opinion on this topic that they want to weigh in on?
I don't have a strong opinion about this either, and that's the problem here. Nobody cares enough
Yeah,
to
I mean, my
say,
point.
yes, we have to
I
do
think
this.
this is like, I mean, I guess I would do like a design taste thing, which is like Martin thinks simple is good, and I think flexible is good, and that like I'm just like sad that we're gonna like someday have an extension that is like, you know, that is like you know, another 200 bytes, and the server's gonna want to send, and the client's going to burn 4 bytes to say go ahead and send it. And I think Martin thinks that doesn't make a difference. So that's the sum total of our disagreement.
I think the tricky thing here is to find some good uses of the flags extension, and then to actually see whether that's practical, because it would be annoying if there are a few extensions that can make use of it, and then they can't be used because of some other constraints that you put in there, and that makes it completely useless.
So I'm perfectly happy making another PR that says, yes, it is okay to do this, and then we can pick either one of those PRs and commit them to the text.
Okay.
Or anyone else can do this, that other PR.
Ben Kadek, yeah. Basically, same things that have already been said. We should be clear about whether it is or is not allowed. I don't have a strong opinion. I tend to have my intuition be the same as Martin, that you should not allow it. But if we can come up with reasons we like that we should allow it, I think, I don't know of a reason that's a fatal flaw. I don't know of any vulnerabilities with it.
Oh, and let's imagine a silly extension. We have the terms and condition extension that we get from the server, the terms and condition for using it. And so we only have to send this one bit from the client and then get the whole terms and conditions, as opposed to sending a whole 4 bytes of I want the terms and conditions, forgetting it. But that's just a silly example.
Yeah, I mean, that's the kind of thing I was thinking of. Look, I mean, we rarely hum here because we usually have consensus, but like, I think every possible argument in favor and against this has been already stated. So I suggest we just hum and live with it.
Good. All right, let's quickly do a hum then. Can you pull up the show of hands tool? What? Yeah, hypertone.
Count me as don't care.
The PR text is in the chat. We dropped it in there. You want to?
You can share a screen, not just.
No, we're having technical difficulties, so we can't share the screen. Text as for a flag that does not require a response. The only proper response is the same flag and a flag extension. This extension must not be used to specify extensions where the response is a proper extension with content. Okay, so we just put up a quick show of hands with the title "Disallow Non-Flag Responses," which is basically the PR as written. And if you are supportive of this PR, raise your hand. I guess not supportive and you want to go with the opposite route, do not raise your hand. If you do not have a strong opinion, nothing. Sorry, it's a virtual show of hands. It's a hybrid meeting. You have to do virtually. Okay. It seems like it's going in towards the current PR. So 15 to 7.
So
so
merge it.
Let's merge the PR. Thank you for all of your opinions and thank you for attending TLS. Yeah, we finished on time. Oh, Jesus.
Oh, it's an hour and a half. When is it?